Yesterday we talked about the differentiation, right? We defined this. We said by the definition, if we have the function f, its derivative at the point x is defined as the limit of delta f over delta x, where delta x goes to the 0, right? And we also denoted this as df dx, right? We say that so Newton and Leibniz are contributed to the subject, to the development of the subject a lot. And Leibniz introduced this notation. So this notation means the derivative, okay? So do you remember what we say this one?
Average change.
Average change. What?
Instantaneous.
Okay, so if f means the distance, then delta f over delta x means the average velocity, right? Or in general case, if, for example, f is velocity, what is the delta f over delta x?
Instant velocity.
If f is velocity. If f is distance, okay, let us write this.
Changing fraction, you mean?
If f is a function of distance, then delta f over delta x means average velocity, right? Average velocity in between what? In between the 2 points, right? Where delta x means the distance between these 2 points, right? Okay, so if f is a function of velocity, then delta f over delta x is average acceleration. Right? Okay. Yes. So if f is in general some function, delta f over delta x means the average change of this function in the interval of between 2 points, where delta x is the distance of these 2 points. Okay? So basically, if we draw the function, if this function means something, let's say this is our function, and which is the 2 points x1 and x2, okay, where the distance between these 2 points will be delta x, okay, so this is defined as x2 minus x1, right? So the delta f is the, what is the delta f, by the way? So graphically, so if I draw the delta f, this will be the delta f, right? The change of your of your function, okay? So delta x is the change of your points, and delta f means the change of the value of the function, okay? So if you divide the delta f to the delta x, it means the average change of your function, okay? How your function has been changed from x1 and x2 in average, okay? This is the meaning of delta f and over delta x. So when we take the limit of delta f over delta x, where delta x becomes really small, we say that this is the instant change of this velocity, or of this function, okay? How your function is changing at this point, right? So if we say, okay, so hey, if this is the curve of the distance, then its derivative, or its delta f over delta x in the limit, which is df over dx, means how the distance is changing at this point x, okay? If this curve means the velocity, and the df over df dx at some point means the instant change of the velocity, right? Which means the acceleration, okay? If this function means the profit, for example, right? During some period of time, okay? So where this will be the time, okay? In days, for example. And if you choose one point here, right? And if you calculate df dx, it means how your profit is changing exactly at this time stage. Okay? So previously we've learned how to calculate the slope of the straight lines, right? Do you remember how to calculate the slope of the straight line? Let's say I've got a function y is equal to the 3x minus 1. How to draw this function? So I see that this is the line, right? So I need 2 points in order to draw this line, okay? So I choose x to be equal to the 0. What will be the y? Minus 1. This will be my first point. So here somewhere. When I choose the y to be equal to the 0, what will be the x? 1 over 3, right? When y is equal to the 0, x is 1 over 3. So the second point will be somewhere here, right? 1 over 3. Then I just need to connect them, okay? So this will be my line, okay? Now I would like to understand what is the slope of this line. I would like to measure this. In order to measure the slope of this line, you need to always choose the 2 points, okay? So you can choose any 2 points. For example, you can choose x1 to be equal to the 1 and x2 to be equal to the 0, for example, or vice versa, sorry. x1 to be equal to the 0, x2 to be equal to the 1. Then what will be the slope? The slope is the value of your function at the point x2 minus the value of your function at the point x1 divided to the x2 minus x1. What is your value at the point x2? If you substitute x was the 1, what will be your function? 3 multiplied to the 1 minus 1, it is 2, right? If your point is 0, what will be the value of the function? Will be minus 1, right? So minus 1 divided to the 1 minus 0, which is 3, right? It gives you the slope. So no matter which 2 points you choose here for this function, if you find the slope using this formula, it gives you always 3, okay? Because the line has the slope always the same, right? Okay. So in terms of like a meaning, it means that at every point, the function is, so the instant change of the function is the same, okay? Now, it's more or less clear how to measure the slope of the lines, right? So how to measure the slope of this kind of curves? Because we said, okay, so I know what does it mean, the average change, right? What does it mean in terms of geometry? It means that I need to choose these 2 points, I need to connect them with the line, right? And the slope of this line means the average change, right? So using the same formula here, right? Do you see this? I'm choosing that point, right? Minus this point, right? On this line. And divide this to the delta x. It gives me the average change, right? Between 2 points. Now, I would like to know what is the instant change at this point, for example. Or at that point. How to measure this? Using the tangent line, right? Okay. So if I would like to measure the instant change of the function at this point, we need to draw the tangent line, right? And the slope of this tangent line means actually the derivative of this, the value of the derivative of this function. Okay? So when we say, okay, so the slope of this curve, we always mean actually not the slope of this curve, we mean the slope of this tangent line. Okay? Because we know how to measure the slope of the lines. Okay? Good. Yesterday we started talking about the derivatives of the trigonometric functions, right? Derivatives. So we say that derivative of the sine, or let's say f of x is equal to the sine of x. We know its derivative is equal to the cosine of x, right? And we can show this using the definition of the differentiation, right? So we say that the derivative of the function f is equal to the limit of delta f over delta x, where delta x goes to the 0, right? Then we can write this down. So the limit of, what was the delta f? Is f at the point x plus delta x minus f of x, right? This gives you delta f, right? So have your function, so basically the difference of how your function is changed, right? In this between these 2 points. Divided to the delta x, where delta x goes to the 0. Now I need to substitute my function here, right? So if f of x is equal to the sine of x, what is f of y? Sine of y, right? What is f of x plus delta x? It's sine of x plus delta x, right? Okay, this is equal to the sine of x plus delta x minus, what is f of x? Sine of x divided to the delta x, right? Then we can open up the first term using the law of the summation of the angles of the trigonometric functions. It will be the sine of x cosine of delta x minus, right, or plus? Plus cosine of x sine of delta x minus sine of x over delta x, right? Do you understand that this is equal to sine of x plus delta x, right? Okay, so now I see that there is sine of x here and there is sine of x here, okay? I will take them out of the brackets and I will split this limit into the 2 parts, okay? We'll write this. The limit of sine of x. So if I take out the sine of x from this term, what is left?
1 multiplied by 4.
Cosine of delta x, right? If I take out the sine out of here, what is left? It's minus 1, right? Divided to the delta x plus the limit of cosine of x multiplied to the sine of delta x over delta x, where delta x goes to the 0. So now, since sine of x does not depend on the delta x, I can take this out to here, right? Do you understand this why? So let's assume, I would like to ask you, what is the limit of 5 plus 4 when x goes to the 3? 9, right? Independently, what is the x, right? Okay, so the same story here. So sine of x doesn't depend to the delta x, right? So that is why I can take this out, okay? We can write this as the sine of x multiplied to the limit of delta x goes to the 0, cosine of delta x minus 1 over delta x plus, here the same, I can take out the cosine of x out of the limit, and it will be the limit of sine of delta x over delta x, where delta x goes to the 0, right? And yesterday we say that this is equal to the 0, this limit is equal to the 0, and this limit is equal to the 1. So that is why sine multiplied to the 0 plus cosine multiplied to the 1 is equal to the cosine of x, right? So yesterday we started proving the first limit, the limit of the sine of delta x over delta x is equal to the 1, right? We show this using the theorem, which is called the sandwich theorem, right? Do you remember this? We showed graphically that the sine of x is always less than x, right? And also the function tangent of x is always more than x, right? So if I take out so for x is positive, okay? For the positive x values. So since x is positive and since the value of the sine is positive, for x is positive, I can take out the sine x to here, right? It will be equal to the sine of x over x is less than 1. Okay? And I will write down the tangent as sine of x over cosine of x, which is more than x, right? Now if I put the x to here and cosine to there, I will get the inequality sine of x over x is more than cosine of x, right? If I combine these two inequalities, we will get the big inequality, which tells you sine of x over x is less than 1, right? But more than cosine of x. Okay? Do you see this? So sine of x over x is more than cosine of x. This is the first part of this inequality. And sine of x over x is less than 1. This is the second part. Okay? So when I take the limit, when x goes to the 0. Okay? So the limit of the three parts together. So what will be the limit of the cosine of x when x goes to the 0? 1. Right? So this part is also 1. Right? So since the right hand side part and the left hand side part goes to 1, then this middle also should go to the 1. Okay? So that is why the limit of the sine of x over x is equal to the 1. So the limit of x goes to the 0. From here we obtain that the limit of x goes to the 0 of the sine of x over x goes to 1. Okay? Do you remember we said that we need to calculate these limits independently, not independently, together, right? So when we see this kind of ratio, we are like it is important for us to understand this, right? If I just see how the sign is changing, how the sign is reaching the 0, when x tends to go to the 0, the sine of x also goes to the 0, right? When x goes to the 0, this part is also going to the 0, right? Separately, it will go to the 0, and this will go to the 0, and we don't know how to divide them, right? So we need to look at them together, okay? So when the limit of the sine of x over x is equal to the 1, it means that they tend to reach the 0 more or less in the same time, okay? At the same time. Do you understand this? So they reach the 0, they reach the destination more or less in the same time. Okay? So you need to understand this. What is the ratio of their speeds? Okay? Do you remember yesterday we talked about this? If you would like to go to Samarkand in the car and in the bus, if you divide the time which is needed for both of them, right? More or less they will reach this in the same time. More or less. Okay? 4 or 5 hours. More or less. Okay? Now let's talk about the second limit. It was the limit of delta x goes to the 0, cosine of delta x minus 1 over delta x, right? We need to prove that this is equal to the 0, right? In terms of this kind of example of the speed, what does it mean for this limit? So do you remember what is the 0 divided to some number? Is 0, right? So we need to understand this. Okay, so when delta x, do you remember? So last semester we did this kind of example, how to calculate the limits. So you take some value which is near 0, right? For example, you take the value of delta x is equal to the 1, then you take 0.5, then you take 0.1, 0.01, 0.001, right? Then you evaluate this function, right? And you will see where it is going, to which value. Whether it is going to somewhere, and if it is going to somewhere, to which value it tends to go, right? Okay, so here, in terms of the speed, it means that when delta x goes to the 0, right? So this also goes to the 0, right? Because the cosine of delta x will be 1, and 1 minus 1 will be 0, right? And this one is also going to the 0, right? But the thing is, this one goes to the 0 much faster than this one. Okay? So basically, I'm taking the plane to go to the destination, and you're going to take the car to go to the destination. And when I reach the destination, you are still there in the origin. Okay? For example, we're going to Almaty from Tashkent. I take the plane, and you take the car. Okay? The old car. So when I reach the Almaty, you are still in Tashkent. Okay? This is what does it mean. When this function reaches the 0, this one is still some number. Okay? Some reasonable number. Some small number, but this is still not 0. Okay? So that is why you can take this as a 0 over some number, which is 0. Okay? Do you understand this? What does it mean? Now let's try to prove this. So limit of delta x goes to the 0. Cosine of delta x minus 1 over delta x. We will multiply the both parts of this ratio to the cosine of delta x plus 1 and cosine of delta x plus 1. Okay? So if I do this, the ratio do not change. The limit of delta x goes to the 0. If you multiply numerator, what you get? Cosine square of x, right? Delta x minus 1, right? Cosine square of delta x minus 1. Divided to delta x cosine of delta x plus 1. Right? Okay. So do you remember what was 1? Or is it possible to express the 1 using the sine and cosine? Right? How? Cosine square plus sine square, right? I can write the 1 as the cosine square plus the sine square. So this can be written cosine square of delta x plus sine square of delta x. Do you remember in the last lecture we proved this, right? Using the Pythagorean theorem, right? You can write down this. Okay, so what is left in the denominator? What is left in the denominator? Cosine square minus cosine square minus sine square. What is left? Minus sine square, right? So minus sine of delta x multiplied to the sine of delta x. Okay, let me write them separately. Divided to the delta x cosine of delta x plus 1. Okay? Now, the reason why I wrote them separately is that I would like to write this as two separate limits. Okay, I would like to write this. The limit of, let me take out the minus to here. Limit of delta x goes to the 0 of the sine of delta x over delta x multiplied to the limit of sine of delta x divided to the cosine of delta x plus 1. Okay, so if you would like to find the limit of the multiplication of the two functions, there is a rule that you can find the limit of each of them, then multiply the result. Okay? So the limits are really nice operations. Okay? Do you understand this? So here I split this function as this one is the 1. Okay? This one is the second because their multiplication gives you again the original one. Right? So what is the limit of this function? 1. Right? Yes? Because we just proved this. Okay? What about this? Okay, so what is the limit of the sine of delta x when delta x goes to the 0? 0. What is the limit of the cosine delta x plus 1? 1 plus 1, 2, right? 0 over 2 gives you 0, right? Okay. So this will be, first one is 1, the second one is 0 over 2 or 0, which is equal to the 0. Okay? So the limit of this function is equal to the 0. Okay? So now, using the same techniques, what you need to do is you need to prove that if you take the f of x as the cosine of x, show that its derivative is equal to the minus sine of x. Again, using the definition, right? Prove that the derivative of the cosine is minus sine. Okay, let's do this together. So the f prime is equal to the limit of delta f over delta x, right? So where delta x goes to the 0. So first of all, let's find the delta f. So delta f by the definition is change of the value of your function, right? So it will be f of x plus delta x minus f of x. What is the f of x? Cosine of x. If f of x is the cosine of x, then f of x plus delta x will be cosine of x plus delta x, right? With the minus. Now, using the formula for the addition of the angles, we can open up the cosine. So we can write as cosine of x, cosine of delta x, right? Minus sine of x, sine of delta x, minus cosine of x. Because there is a formula. Cosine of alpha plus beta is equal to cosine of alpha, cosine of beta, right? Minus sine of alpha, sine of beta. If it would be minus here, then it would be plus here. Okay? And there is a formula as well for the sine. So sine of alpha plus minus beta is equal to the sine of alpha cosine of beta plus minus cosine of alpha sine of beta. Okay? For the sine, it is plus minus. Plus minus goes to the plus minus. For the cosine, plus minus goes to the minus plus. Okay? So here, I will take out, I see that the cosine of x here, and there is also cosine of x, right? Because if I see that the sine of x is nowhere else, right? So that is why we need to take out the cosine of x out of the brackets. It will be cosine of x, cosine of delta x, minus 1, right? Minus sine of x, sine of delta x. Okay? So now, I found the delta f. We need to divide the delta f to the delta x and find its limit, right? So if you divide this, you can divide this part separately, then this part. Okay? We can write as cosine of x multiplied to the limit of cosine of delta x minus 1 over delta x, right? Minus sine of x, the limit of sine of delta x over delta x. Okay? So we just proved that this is equal to the 0 and this is equal to the 1, right? So that is why it will be minus sine of x. Okay? So how to show what is do you remember what was the derivative of the tangent? So if f of x is equal to the tangent of x, the derivative of the tangent is equal to the 1 over cosine square of x. Okay? So we can show this using the definition as well, but it is better to do this using the quotient and the multiplication rules. Okay? So let us define this. So multiplication rule. It tells us, let f of x is equal to the h of x multiplied to the g of x. Okay? Then f prime, the derivative of the f, is equal to the h prime of x multiplied to the g of x plus h of x multiplied to the g prime of x. Okay? We can prove this using the definition. Okay? So this is your homework. You might get a problem in the exam to prove this. Okay? Right? So there is another rule which is called the quotient rule. You're being taped. You need to keep the silence. Okay? So f of x is equal to the h of x over g of x. Then the derivative of this function is equal to the h prime of x multiplied to the g of x minus h of x multiplied to the g prime of x divided to the g square of x. Okay? So let's say, okay, so let's say you need to prove this at home. If you have any questions, you need to come and ask in the lectures or after the lectures, okay? So take it serious. I will ask you the questions in exam. Okay? So let's say our f of x is equal to the tangent of x, which can be written as the ratio of the sine to the cosine, right? Is it similar somehow to this function? Right? So where the h of x will be equal to the sine of x, right? And g of x will be equal to the cosine of x, right? Then in order to find the derivative of the f, I just need to use this formula, okay? So what is the h prime? So we just found out that the derivative of the sine is equal to the cosine of x. And what is the derivative of the g? Is minus sine, okay? So I just need to substitute everything to this formula here, okay? So derivative of the tangent of x, okay? It is equal to h prime. What is h prime? Cosine of x, right? Multiplied, what is the g of x? Cosine of x minus, what is the h of x? sine of x. What is g prime of x? Is minus sine of x. Right? I'm putting everything to this formula. Divided to, what is g of x? Cosine square of x. So this minus with this minus becomes plus, right? In the numerator we'll have cosine square of x plus sine square of x, right? So we have cosine square of x plus sine square of x divided to the cosine square of x. And we know that this is equal to the 1, the numerator, right? Over cosine square of x. Okay? So that is why derivative of the tangent is equal to the 1 over cosine square of x. Okay,